In this video, we look at object and edit mode and manipulating primitive meshes. Let's get started. In this introduction to Blender Basics, we look at the fundamentals including object manipulation, basic modeling, materials, lighting, rendering, camera usage, and animation. This short section is designed for absolute beginners to Blender to help them get a better grasp of the software. So if you know the fundamentals, feel free to skip ahead and continue with the next section. Let's begin by coming to File, New, and create a new general blend file. 3D modeling is the process of creating a three-dimensional representation of any surface or object by manipulating polygons, edges, and vertices in 3D space. This can be achieved through a variety of techniques like polygon modeling, digital sculpting, or primitive modeling. One fundamental concept within Blender is its system of modes. These modes govern what operations can be executed on an object and what can be selected in the 3D viewport's header. The modes available are dependent on the type of the active object. When you fire up Blender, the software opens in object mode by default. In object mode, you can interact with whole objects, which means you can select, move, rotate, and scale objects. Moreover, this mode allows you to add new objects to your scene or remove existing ones. Here you can establish properties that apply to the entire object, such as setting up materials, applying modifiers, or defining physics properties. Keep in mind that any transformations you apply in object mode are based on the object's origin point and they impact the whole object. On the other hand, edit mode is where you alter the structure of your object. We can transition into edit mode from the mode menu, or as we'll do throughout this course, by pressing the tab key. This action toggles between object and edit modes. In edit mode, you can manipulate the individual vertices, edges, and faces of an object. Here you can subdivide faces, extrude faces, bevel edges, merge vertices, and more. Essentially, edit mode is where the detailed shaping of the 3D object takes place. Importantly, even in edit mode, you're still working with the same object, but now you're altering its internal structure. To put it simply, object mode deals with the macroscopic view of where objects are in relation to one another, while edit mode enables you to fine-tune the details of each individual object. You'll often find yourself switching frequently between these two modes during a typical workflow in Blender. Let's press tab and switch back to object mode for now. Take a look at this cube. It's a type of primitive object, often used as a base for modeling. When you initiate a new project in Blender, a default cube is typically present right in the middle of your 3D workspace. As you can see, it's simply a geometric shape, a six-sided object that can serve as a good starting point for numerous modeling projects. Blender also provides other primitives such as spheres, cylinders, and cones. I can quickly add these into the scene. Let's move these primitives aside for a better view of each. These basic shapes are frequently used in a method called primitive modeling. In this approach, you start with these basic shapes and then modify and combine them to create more complex models. Depending on the shape of the object you intend to create, the sphere primitive might be an ideal choice. For instance, modeling a character's eyes or the base shape for head sculpting could begin with a sphere. Using these primitives as starting points can save considerable time as you develop your model. Alternatively, a cube can be resized in object mode to approximate the size of an object you want to model. For example, you could quickly create a rectangle top for a table. In the Y dimension field, let's input 3500 mm. Then tab into the Z dimension and input 100 mm. As you can see, you can rapidly transform the dimensions of a primitive cube into an object just by modifying its dimensions. In this video, we look at vertices, edges, and faces. Let's get started. A vertex is a fundamental unit in 3D modeling and computer graphics. In the simplest terms, a vertex is a point in 3D space that has coordinates. In Blender, you can switch between vertices, edges, and faces using the three buttons up top here. Alternatively, use the shortcuts 1, 2, and 3 to switch between each. In the sidebar, shortcut N Here the coordinates of each vertex get displayed when selected. So if we select this top corner vertex, we can see that the coordinates are 1 in the x, -1 in the y, and 1 in the z. Now you may realize something as you look at these. 1 meter in the z doesn't add up, nor does the y coordinate. We changed the size of this table top to be 100 millimeters in the z and 3500 in the y. When you make changes to an object dimensions or scale in object mode, the scale needs to be applied before the mesh updates. It works from the old data until being applied. This is true for UVs, modifiers, and right across Blender. So if we press tab and come back here, we'll notice that the scale on the Y and Z are non-uniform and need to be applied. So let's press Ctrl+A and apply that scale. So now, if we tab back in here, we can see that the mesh data has updated to correctly represent the vertex positions. Vertices are used to define the shape of polygons in 3D modeling. They serve as the corners or endpoints where edges of a shape meet. You can move a vertex in any direction to change the form of the model. Use the Move manipulator to drag and reposition. While you can accurately position the vertex using the fields, more often you'll use the Move manipulator to position them. In addition to defining the shape of an object, vertices can also hold additional information that influences how the object is rendered. This can include data like color, texture coordinates, normals, which determines how light interacts with the surface, and weights for skeletal animation. So not only being a point in space, but in combination with other vertices, define the shape and surface of a 3D model. Next up is the edge. This is a straight line segment connecting two vertices. Together, edges define the structure and shape of the 3D object. Edges can be thought of as wires in a wireframe representation of the model. Edges play an important role in defining the topology or flow of a 3D model, especially in models that will be animated. Good edge flow can help to ensure that a model deforms correctly when it moves. Just like vertices, you can manipulate edges to modify your 3D model. You can select, move, scale, rotate, extrude, bevel, to name but a few. In addition to defining the model's shape, edges can also be used to control shading and appearance of the model. For example, sharp edges can be defined to create a creased or faceted look. There are a couple of ways to add vertices, edges, and faces. You can create an edge between two vertices using the New Edge Face command. That can be found here in the Vertex menu. Works on vertices, edges, and faces. So if we select this vertex, press Shift+D to duplicate, X to restrict it to the X-axis, and just drag this away. If we press and hold Shift and select the first vertex again, press F and this will create an edge. You can also select the vertex and press E to extrude a new edge and form it this way. You can create a vertex center of this edge if you have two vertices or an edge selected. Actually, if we switch to Edge Selection, then select this edge, right-click and subdivide. That splits the edge into two. So if we switch back to Vertex Selection, there is a vertex center. You can also select two vertices and right-click and subdivide to add one center. The options box lets you increase that number if necessary. Faces can also be subdivided, so switch to Face. Select the top face here. Right-click and choose Subdivide. This splits the top face into 4, 2 by 2, along the X and Y. You'll also notice it only subdivides the top face. Let's undo subdividing with Ctrl+Z. If you wanted an edge loop connected all the way around, you can use the Edge Loop tool. Press Ctrl+R to add an edge loop all around the mesh. Left-click and right-click to place center. You can remove a vertex by selecting it, pressing X and delete vertex. However, it also removes the edges connecting. Instead, we can press Ctrl+C and undo. If we press X and choose Dissolve Vertices, that maintains the edges but removes the vertex. You can also dissolve edges and faces without removing connected geometry. In this video, we look at adding edge loops and extruding faces. Let's get started. To begin, let's come to File, New and start a new general blend file. We'll be working with all three objects during this introduction, the cube object, the default camera and the light object. But for now, we'll be focusing on the cube and creating some basic shapes. To get started, select the cube and press the Tab key to enter edit mode. In edit mode, you can scale the object without needing to apply transforms, since you're directly editing the mesh. First, let's scale up the cube along the y-axis to double its length. There are a couple of ways we can do this. You can use the Scale tool by coming over to the Tool shelf, shortcut T. Select the Scale tool. Grab the manipulator along the y-axis and drag it out. While it's selected, input 2 and press enter to confirm the operation. You can verify the scale in the options box below here, where the Y scale field should show 2. Next, let's add an edge loop around the mesh along the x-axis. To do this, let's press Ctrl+R to add an edge loop. When hovering the cursor close to the mesh, you'll get a preview of where the edge loop will be added. Left-click once to control the edge loop, and then you can manually position it. If we just right-click to cancel movement, it will be placed exactly at the center of the face, which is what we want. The reason for adding edge loops is to split the mesh into two top faces. We want to extrude from the back face, so switch to Face Select mode and select the back face. On the tool shelf, choose the Extrude Region tool. Click and drag to start extruding, then input 2 and press enter. You can verify in the options box that it was 2 we extruded. Tab back to object mode for a moment. In the sidebar, under the item tab, you can see the dimensions for the cube. It should now show 2 meters in the x-axis and 4 meters in the y and z. Remember that modifications made in edit mode will be reflected in object mode once you tab back. In this video, we look at the shading modes and selecting mesh elements. Let's get started. With the cube selected, let's tab into edit mode. If any vertices are selected, we can deselect them by pressing Alt+A. Let's come up to the top right corner of the viewport here. This is where you'll find the different shading options: wireframe, solid shading, material preview, and rendered. Let's switch to wireframe shading for a clearer view of our cube structure. A quick tip, you can also access these shading options via a shortcut. Press Z to open the pie menu and select your preferred shading mode. Each mode has a number listed beside it for easy access. For example, pressing 6 will switch to solid shading. Repeating the Z key and pressing 4 switches to wireframe. This quick number selection can speed up your workflow if you are comfortable using the keyboard. Now let's switch our selection tool back to Select Box on the tool shelf here. Depending on what part of the mesh you want to work with, you can toggle between vertex, edge and face selection modes. You can do this either from the menu at the top or by pressing the keys 1, 2 or 3 respectively. In vertex selection mode, you can easily select any vertex on the mesh, indicated by black highlights on the corners. Switching to edge selection mode, you can select any of the edges, also highlighted in black. Similarly, in face selection mode, you'll see a black dot that represents the center of each face, which you can select. Let's switch to edge selection mode and select the top edge on the cube. Our goal is to move this edge back by 1 meter. This can be achieved by pressing G for move, followed by Y to restrict the movement to the y-axis. Input 1 and press enter to confirm the movement. If you wish to adjust the move properties after the transformation, you can do that in the properties box located at the bottom. Alternatively, you can also adjust the edge movement along the y-axis in the item tab at the top of the viewport. This flexibility allows for precise control and modification of your 3D models in Blender. In this video, we look at how to duplicate and mirror an object and correcting reversed normals. Let's get started. Let's continue from where we left off in the last video. In edit mode, our next step is to duplicate and mirror half of this model along the y-axis to construct the back half. There are multiple ways to do this, but let's start with the mirror command. When you mirror an object in Blender, you mirror it around a pivot point. In our case, this pivot point will be the 3D cursor. So we first need to position the 3D cursor to serve as the pivot. Select this bottom edge here. Press Shift+S to open the snap menu and then select Cursor to Selected. You can also find the snap menu at the top in the Mesh menu, where you can also choose Cursor to Selected. To utilize the 3D cursor as the pivot, we need to switch the pivot point to the 3D cursor. You can do this from the Pivot Point menu. Now select all vertices by pressing A. We're going to duplicate these vertices, then mirror the duplicates. To duplicate, you can come to the Mesh menu and select Duplicate. The shortcut for this is Shift+D. As soon as you duplicate, you gain control to position the vertices. But right-clicking will cancel any movement. To mirror the selected vertices, let's return to the Mesh menu, and here you'll find the mirror command, Interactive Mirror. Let's select that. This command becomes open. As you can see at the bottom, you have a list of commands available. The first allows you to choose an axis, X, Y, or Z. We want to mirror along the Y-axis, so input Y and press Enter to complete the command. There is one caveat when using the mirror command. If we switch to solid shading from the shading menu, then if we come to the overlays menu, we can activate face orientation. You'll notice that the faces are red, indicating reversed normals. To fix this, select everything by pressing A. Then press Shift+N to recalculate the outside normals. This step isn't critical for these videos, but it's good practice to follow. Now let's turn off the face orientation overlay from the overlays menu. We can also switch back to wireframe shading. Lastly, we need to remove the internal faces connecting the front and back sections. Switch to face select mode. When we mirrored the model, we also included the end faces, which have now become internal faces. Let's select these faces. There should be 4 in total. Press X and we can delete faces. Ensure all 4 are deleted. The small black dot center can help identify faces. In this video, we look at how to merge vertices and how to use the snap command and its relationship with the zoom level in the 3D viewport. Let's get started. In the previous video, we duplicated and mirrored the vertices on one side of our model. However, while these duplicate vertices are positioned identically to the original, they are not connected. If you select one and press G, it separates from the center. You can cancel this action by right-clicking. This situation often occurs when you duplicate or snap vertices. The only time vertices are inherently connected is when you extrude them. To connect these separate vertices, we can use the merge command. But before we do that, let's turn on statistics in the overlays menu. This feature gives you a count of the objects, vertices, edges, and faces. Now select all vertices by pressing A. This now displays 32 vertices, and we know that 6 of these along the center need to be merged. In the Mesh menu, let's navigate to the Merge submenu, and in here we can select by distance. The information reading at the bottom indicates that 6 vertices were removed. The merge command combines the vertices that are within a certain distance of each other, in this case 0.1 millimeters. The vertex count has now updated to reflect the new number. If you select one vertex in the center now and press G, you'll see that the duplicate vertices have been merged into one. It's crucial to regularly check for and remove overlapping or duplicate vertices, as these can lead to issues with shading, UV mapping, and more. Our next step is to form the wheel wells. Let's switch to Edge Selection mode, then press and hold Shift to select these 2 edges. Now let's move into a side view by clicking the View gizmo, and also switch to an orthographic projection for a full side-on view of the model. The default snap type in the snap menu is increment, which allows you to snap in set increments depending on your zoom level. For me, this level is displayed as 10 centimeters. However, note that you won't see your zoom level if you're in a perspective view, so you need to be in an orthographic view for this to be visible. Let's switch the pivot point back to medium point in the pivot menu and activate the move manipulator in the tool shelf. Instead of switching on snap, we can activate it using the control key. If you click and drag on the Z axis and press Ctrl for snap, you'll see that we're snapping in increments of 10 centimeters, as displayed at the top. Above this is the actual distance we're moving the vertices, which in this case is 1 meter. We can position these here. To illustrate how zoom level affects snap distance, if I zoom out to a level of meters, grab this arrow and press Ctrl to activate snap, you'll see it snapping in increments of 1 meter at a time. So remember, your zoom level significantly influences your snap distance. In this video, we look at insertion points for new objects and how to correctly apply rotation and scale transforms. Let's get started. The next step is to add the wheels. But first, we need to set an insertion point for the cylinder object that will form the wheels. Switch to vertex selection and select the 2 bottom vertices on the wheel well. Press Shift+S to open the snap menu and select cursor to selected. Although we could add a cylinder in edit mode of the current object from the add menu, we want the wheels to be separate objects. So let's switch back to object mode first. From the add menu in mesh, let's add a cylinder. To visualize this better, let's press Z and switch to solid shading. We'll need to rotate the cylinder, which we can do in the rotation transform field. In this case, we want to rotate the wheel around the Y-axis. The rotation gizmo can be useful for determining the correct axis. Click in the Y field and input 90 to orientate the wheel correctly. We also need to scale down the cylinder a bit. Let's click and drag in the XYZ fields in the scale transform section. This lets you input and update all 3 value fields simultaneously. Input 0.8 here to uniformly scale the cylinder down. Now we want to scale the cylinder along the x-axis to get the right width for the wheel. But when I try to scale on the x-axis, it also squashes the cylinder vertically. The reason for this is that the object has a non-uniform rotation transform. To correctly scale it on the x-axis, press Ctrl+A and apply the rotation. Now if we click and drag on the X field in the scale transform section, we can reduce the width of the cylinder. Press the Shift key for smaller increments and reduce this to 0.3. Then press Ctrl+A and apply the scale to solidify these changes. In this video, we look at how to refine and detail using tools such as Inset, Extrude, and the Subdivision Surface Modifier. Let's get started. Next, let's focus on refining the shape of our wheel. We can start by isolating the wheel for closer inspection. Press the / key to enter local view, which is indicated in the top corner of the interface. This view is handy when you want to concentrate on just one object. Now press Tab to enter edit mode. Switch to face select, and we can select the outer face of the wheel. Let's rotate around, and holding Shift, we can select the inner face of the wheel as well. On the tool shelf, select the Inset tool. Left click and drag inward to start insetting the faces. You can input a specific value, but for now let's simply release to finalize the inset. In the inset properties, adjust the thickness value to 0.2. Next, press E to extrude, then right click to cancel movement. Press S, then X and push inwards a little bit. In the scale properties, round the X scale to 0.5. Again, use the Inset tool to create an inset on the outer face. Then in the thickness field, find a value that looks right. A value of 0.5 will work well here. Next, we can switch to the Extrude tool on the tool shelf. select the outer face, then left click to extrude outward. We can input a value of 0.1 and press enter. Next, we can navigate to the Modifiers tab, and here we can add modifier and add a subdivision surface modifier. Increase the levels on the modifier to 2. The subdivision surface modifier smooths and refines the appearance of a 3D model by subdividing its faces and edges, which is ideal for creating smooth shapes. To further control the smoothing effect, press Ctrl+R to add an edge loop. Hover over the area where you want to add the edge loop. Then use the mouse wheel to increase the number of edge loops to 2. Left click to confirm. Then right click to exit the tool. Press S, then X and drag outwards slightly to reduce the rounding of the corners. Press Ctrl+R again to add an edge loop within the wheel. Left click and push inward. Then left click again to confirm. Switch to Face Select and select the outer face. Switch back to the Insert tool and make a small inset. Inset once more. Then press M and select Merge at Center. This combines the vertices to one at center. Finally, add an edge loop inside the wheel by pressing Ctrl+R. Push this inward to add more shape to the wheel. In this video, we look at assigning different materials to specific parts of the 3D model and how to modify material properties such as base color and metallic values. Let's get started. Now let's add some materials to the different parts of the wheel. But first, the cap of the wheel needs a little edit to help define the transition from the hub. To help with that, in the Modifiers tab, on the Subdivision Surface modifier, enable this on-cage setting. That way, we get a better preview of the effect of the modifier without the overlay. Let's add an edge loop now. Press Ctrl+R and left click, then push in and add a little definition here. Head over to the Materials tab now. Start by clicking New to add a new material. Then in the name field, let's rename this tire. Press Enter to finalize. In the base color option, click the color swatch and darken it towards a black color. If you hover the cursor over the color field, we can press Ctrl+C to copy that value. This will be useful in a moment. We can preview the colors in the viewport, so let's scroll down towards the bottom of the Material tab. Look for the viewport display area. Click and drag it right to the top for easy access. Now expand it. Hover the cursor over the color field and press Ctrl+V to paste in the color value we just copied. This gives us a viewport representation of the color. Instead of having to switch to rendered or material preview, you can stay in solid shading and preview materials in the scene. Let's switch to Face Select mode. If we press and hold Alt, then left click, we can select these internal faces of the tire. Rotate the view to the opposite side. Press and hold Shift and Alt select the corresponding faces here. Then press Ctrl+Numpad+ to expand the selection by one face. Back on the Material tab, click the plus icon to add a second material slot for the rims. Click New to create a new material. Let's rename this to Rim. Adjust the base color. I'm just going to make this a lighter shade. Hover over the color field. Press Ctrl+C to copy that value. Then we can Ctrl+V to paste it into the viewport color field. You'll notice that the color hasn't changed yet. This is because we need to assign this new material to the selected faces. Click the Assign button and the material gets applied to the selected faces. Finally, we can add a material to the center cap on the wheel. Let's drag and select the front faces on the hub. Press Ctrl+Numpad+ twice to expand the selection. Over in the Material tab, add a new material slot. Then create a new material. Rename this to Cap. Adjust the base color to a dark shade. Then scroll down further and increase the metallic slider to 1, giving it a metallic material appearance. Hover over the base color field, press Ctrl+C to copy the color value. Then paste it into the viewport display color field using Ctrl+V. Finally, assign this material to the selected faces. We can return to object mode by pressing Tab. Then we can right-click and choose Shade Smooth to smooth out the faces and give the wheels a more realistic appearance. In this video, we look at how to set up environment lighting and how to use the Dynamic Sky add-on to create a procedurally generated sky environment. Let's get started. Let's begin by pressing the / key to return to Global View. Before we proceed to finalize the car's material, it's an opportune time to set up some environment lighting. This will allow us to preview the materials in a manner that closely resembles their appearance when rendered. Blender provides several lighting options for your scene, such as high dynamic range images, scene lights, and 2 other options that we can explore now. Firstly, let's head over to the Render Properties tab. For this demonstration, we'll switch the render engine to cycles, as the first option we're about to use is only supported in this mode. Next, switch to the World tab. In the Surface section, click on the small yellow dot next to Color. From the options that appear, select Sky Texture. For a better view of what we're doing, switch to the Shading workspace. This is a dedicated workspace for editing materials and lighting. Change the data type drop-down to World to display the nodes related to this lighting setup. In the 3D view, press Z and switch to Rendered mode. You can now see the rendered sky in the background. The Sky Texture node has several adjustable settings, such as sun size, intensity, and elevation. As you lower the elevation value, it changes the sun's position on the horizon, altering the color of the sky. Rotating the 3D view allows you to see these changes more clearly. Adjusting the rotation and elevation of the sun can create various effects suitable for different scenes. Now let's explore the second lighting option, which is an add-on. Head over to Edit and open Preferences. In the Add-ons section, search for Dynamic. Then enable the Dynamic Sky add-on. Additional information about the add-on can be found in the documentation link provided. We can close the Preferences window. Press N to open the sidebar. Then we can come to the Create tab, where the Dynamic Sky add-on is available. Click on Create to generate a new dynamic sky. Then we can switch to the World tab. From the drop-down, we can change the environment texture to the dynamic sky we just created. This add-on gives you a different style of environment lighting. Rotating the view shows you a sky filled with clouds. You may need to reselect the dynamic sky from the menu if the settings fail to appear. Then the settings for this procedurally generated sky can be adjusted, but for now I'm going to stick with the default settings. In this video, we look at how to use the bevel modifier to soften the edges of the 3D model. Let's get started. Let's begin by returning to the Layout tab. We can click the camera button to switch to the camera view. From there, open the View tab and tick on the Lock Camera to Selected checkbox. This allows us to navigate within the camera view, so we can adjust our view of the car. Once you're happy with the framing, you can untick the checkbox to lock the camera in position. If you try to rotate the view now, you will simply exit the camera view. Click the camera button again to return to it. Now let's switch to the material preview to preview the material. Ensure that the car is selected and navigate to the Materials tab. If you don't already have a material on this car, then click New to create a new material. Let's rename this material to Car. Moving down to the base color, let's change it to a rich red color. We can also adjust more material settings to enhance its look. For instance, reduce the roughness value to 0.2 to increase the shininess of the material. After setting the base color, hover over it and press Ctrl+C to copy the color value. Scroll down to the Viewport Display section and press Ctrl+V to paste the copied color value. Next, we'll add a glass material to the car. To do this, switch to Edit mode. Hold Alt and select all the upper faces where the glass will be placed. Once you have selected all the appropriate faces, press I to create an inset. The initial inset is connected, but if you press I again, it will switch to individual faces. Set the inset to 0.2 and create a frame for the glass. With these faces still selected, head over to the Material tab. We can click the plus icon to add a second material slot. Click New to create a new material and rename this material to Glass. Click the Assign button to apply this material to the selected faces. Next, click on the button next to the Surface field and switch from the default BSDF shader to a dedicated glass shader. Change the color to an off black. Copy this color Ctrl+C and paste it Ctrl+V into the Viewport Display color field. Now switch back to Object mode. At this stage, the edges of the car may appear too sharp. To address this, let's come to the Modifiers tab and add a bevel modifier. Adjust the amount and maybe reduce it first. If we increase the segments to 6, it's then possible to give the edges a nice rounding, mitigating the sharpness. We can right-click on the car now and shade smooth. In this video, we look at how to set up and use drivers to create a relationship between different objects and properties, and how to use the mirror modifier to create identical copies of an object along an axis. Let's get started. We'll begin by setting up drivers that will make the wheels rotate as the car moves forward. Start by selecting the car and press F2 to rename it as car for easier identification. The updated name will also reflect in the outliner. Next, select the wheels. Then open the Item tab. In the X rotation field, we can right-click and choose Add Driver. This will open the driver properties. If you happen to move the cursor away, the window will disappear. Simply right-click again and choose Edit Driver. In the Expression field, we can remove back to VAR. Then add multiplied by -1. For the object, we can click in here and find and select car. For the type, we can choose the Y location. Now, when the car moves forward, the wheels will rotate accordingly. However, it might be hard to see if the wheels are rotating. To make it more obvious, we'll add details to the wheels. Select the wheels and switch into Edit mode. Hold Alt and select the rim of the wheels. Then, from the Select menu, we can use Checker Deselect to deselect every other face. Press E to extrude these faces out slightly. We can tab back to Object mode. Now when we select and press G to move the car, it's easier to see the wheel rotating. Next, we want the wheel to actually move along with the car. The easiest way to do this is by parenting both objects to an empty. Select the car and switch to Edit mode. Switch to Edge Selection mode. Select the bottom center edge of the car. Then press Shift+S and choose Cursor to Selected. Then switch back to Object mode. From the Add menu, we can come down and from Empty, add an empty plane axis. An empty is a point in space which can control the transforms of other objects. To parent the car and wheels to the empty, first select the wheel. Then press and hold Shift and select the car. And finally the empty. The order of selection matters here, so make sure the empty is selected last. Press Ctrl+P and choose Object Keep Transform from the Parent menu. Now, if you select the empty and move it, both objects will move together. To duplicate these wheels, one of the easiest ways is to use a mirror modifier. Move to the Modifiers tab and add a mirror modifier. Move it to the top of the stack as we want to apply it soon, and modifiers need to be applied in order, top down. Right now it's not doing anything because the origin of the wheel needs to be set at the center of the car. Luckily the 3D cursor is at the center. So with the cursor at this point, right click and choose Origin to 3D Cursor from the Set Origin menu. As you do this, the wheel will update on the other side along the X-axis. Also, enable the Y-axis to mirror the wheels to the back of the car. Now select the empty. Press G, Y, and the wheels will rotate from their origin point. We need to separate these wheels into individual objects and set their locations back to their centers. We can start by applying the mirror modifier. So over here from the drop down, apply the modifier and make the geometry permanent. Then switch to edit mode. Press A to select all, then press P to separate by loose parts. This separates each wheel into an individual object. Let's tab back to object mode. Next, set the origin of each wheel back to its center. Right-click and choose Origin to Geometry. This will place the origin at the center of the geometry. Now we can use the shortcut Shift+R to repeat the last operation for the remaining wheels. Finally, if you select the empty and move it along the Y-axis, all wheels will follow and rotate correctly. In this video, we look at how to use the array modifier to create multiple instances of a mesh along a specified axis. Let's get started. Next, we can create the roadway. Let's use the view manipulator to come into a side view. Zoom in to a level of 10 centimeters. That way we can press G, Z, press and hold Control and snap up along until the wheels are sitting on the green line here. Let's put the cursor back to world origin. To do this, press Shift+S and choose Cursor to World Origin. Then from the Add menu in Mesh, let's add a plane. Let's scale it up. So press S, input 10 and enter. Before we edit this, let's apply that scale. So press Ctrl+A and apply scale. Now let's tab into edit mode. We can press Ctrl+R to add an edge loop. We want this running along the Y-axis. Use the mouse wheel to increase the number to 2. Then we can left click and right click to center it. Then press S, X, and we can scale these out on the sides. These are going to help form grass verges. Let's add another 2 edge loops. So press Ctrl+R, roll the mouse wheel, left click and right click. Then we can scale this in to be the center line on the road. So now let's switch to Face Select and select the 2 outside faces. In the Material tab, let's click New to create a new material. This one will be the roadway, so let's rename this to Road. Then we can add a second material slot. Create a new material. Let's rename this to Grass. Then let's add a third material slot. Create a new material. Let's rename this Line Marking. If we select the grass, we can give this a dark green color. Use Ctrl+C to copy that color. Down below, paste it into the viewport display. We can also do the same for the road. Let's darken this. Press Ctrl+C to copy. Down below, press Ctrl+V to paste. With these 2 faces still selected, let's select the grass material slot and hit Assign. Select the center face on the road, then select the line material and we can assign that here. Let's tab back to object mode. If we come to the modifiers tab, in here we can add an array modifier. The array modifier creates an array of the selected objects, in this case our roadway. Now currently it's arraying this object along the x-axis and that relates to the factor x value of 1 here. Instead, let's input 0. In the factor y, we can input -1 because we want this to array along the negative y direction. So when we do that, we can then increase the number. So let's just drag this up to maybe 15 and increase our roadway in length. Let's take a look at what we have so far. We can press Z and switch to rendered preview. That's beginning to look pretty good. Now one thing you'll notice is this lamp is causing a reflection on the plane. In the light properties, let's switch this to be a sun lamp. We can reduce the value to 1 to reduce the intensity. Then in the scene, let's press G, Z and drag it up out of the way. In this video, we look at setting keyframes that store the location and rotation data for animation and how to create and manage multiple cameras using markers and a Track 2 constraint. Let's get started. Our next task is to animate the car moving along the road, which will be captured by the scene camera, as well as an additional camera that we'll set up shortly. Let's commence by adjusting our first camera to capture the car as it starts to move. For this, we'll have the camera rotate around, keeping the car in frame. Let's switch into the camera view. We can move to the view menu and check on Lock Camera to View. This will allow us to adjust the camera and frame up the car for the desired starting position. Once framed, we can deselect Lock Camera to View. Now, with the camera selected, we can add a keyframe to store its current location and rotation data by pressing I and choosing Location and Rotation. A small yellow dot on the timeline signifies that this keyframe has been added to frame 1. Drag this up to make a little bit more space. The empty object controlling the car also needs a keyframe added at the beginning and end. Select the empty. Press I and add a location rotation keyframe. Then let's move the scrubber to the end of the timeline, frame 250. This animation can be any length, but let's work with 250 for the moment. Next, let's exit camera view. Press G, Y, and drag the car to the end of the road. Press I again to store these transform values. Now, when you press the spacebar, the car moves from the start to the end of the road. Return the scrubber back to the beginning. Let's actually come up to the Layout tab and we can right-click and duplicate layout. We can double-click and rename this Double. This way we have one viewport in camera view and the other to manipulate the objects in the scene. So let's come up and hover the cursor on the top right here. Left-click and drag to create a second viewport. We can jump into camera view in the left side viewport. Let's make some space and close the tool and sidebars with the shortcuts T and N. Let's come into a top view in the right side 3D view. In the timeline, let's drag the scrubber along to frame 50. We can hover the cursor in the viewport, then press R to rotate the camera around to frame up the car at this location. Then press I to insert a location rotation keyframe. So now if we grab the scrubber and drag back, we're capturing the car as it moves off the line. Next, bring the scrubber back to about frame 30 and where the car isn't fully framed. In the scene, let's rotate the camera around until the car is fully framed. We can press I and capture the location rotation values for this new position. That's a little improvement on the shot. Next, let's add a second camera to the scene. Place the 3D cursor at World Origin, so press Shift plus S and choose Cursor to World Origin. We can add the new camera, so press Shift plus A and from the Add menu, add a camera. We can move the camera about 2/3 down the roadway, so press G, Y and drag this down here. We can also press G, X and drag it off the road. We'll use a Track 2 constraint and make this camera look at and track the position of the car. In the Object Constraints tab, let's add a Track 2 constraint. We can select the car as the target object. In the timeline, let's drag the scrubber along to frame 51. Now we need a way to switch between the cameras and we can use a marker for that. So with the camera selected and the cursor in the timeline, press M to create a marker. Now we need to bind this, so from the marker menu we can bind cameras to marker. So now when the scrubber hits frame 51, the scene switches to this camera. We also need to add a marker for the first camera. Select the second camera, so let's bring the scrubber back to frame 1. In the timeline, press M to add a marker. Then from the marker menu we can bind camera to marker. This switches us back to the first camera. Now let's play the animation. We begin in the first camera, and when we get to frame 51, the marker switches us into the second camera, tracking the car as it passes by. In the next video, we'll continue with rendering this animation. In this video, we look at the process of rendering an animation in Blender and how to use Blender's video editing workspace to compile rendered images into a video file. Let's get started. Once you're happy with how your animation looks, we can give this a preview. So let's press Z and switch to Rendered Preview. If you come over to the Render Properties tab, you can now decide whether you want to render with Blender's real-time rendering engine Eevee or with the physically based render engine Cycles. I'm going to render with Eevee just because it will be faster. There are a couple of settings we can switch on to enhance the render. The first is Ambient Occlusion. Ambient Occlusion creates soft shadows that give a greater sense of depth and weight to the objects. This can help make your renders look more real. Also, enable Screen Space Reflections. This is a technique used in real-time rendering engines to simulate reflections in real time. If we come down to Color Management, and in the look, you can set it to something like medium contrast to enhance the colors a little bit more. Let's come to the Output Properties tab. This is where we set up the output file format and folder. This will be rendered out as a sequence of PNG images. Then we'll bring those into Blender's video sequence editor and render a movie file. So make sure the format is PNG. Next, we need an output folder for the 250 images. Click the folder icon and find a folder to save the files. I can put these in my project folder. We'll need these shortly, so remember where to save them. We can accept this. Now to render the images, let's come up to the Render menu and Render Animation. That will work through and render all the images, and I can speed this up. Once that completes, let's close the image editor. I'm going to press Ctrl+S and save this file. That way we can come up to File, New, and start a new video editing file. This opens up into Blender's video editing workspace. It has a video sequence previewer editor up top here and the sequencer down here where we can add the image strips. It also has a properties editor. Let's add in the images we rendered out. So let's come to the Add menu and we can come down and choose Image Sequence. Navigate to where you saved those images. We can press A to select them all, then add image strip. So now if we press the spacebar, we can preview this playing back in the video sequence previewer up here. When you play that through the first time, it caches to memory, so it will play back at the full 24 frames the next time around. The next thing to do now is render this out as a video file. So let's come up to the top right here and to the Output Properties tab. We can come down and by default it's set to FFmpeg and that's going to be fine. We can expand encoding. Here we can use an MP4 container with the video codec of H.264. If you want to add sound effects, you can come down to Audio and from Audio codec choose one from here. AAC or MP3 work well. If you are adding sound files, you can come to the Add menu and just add in your sound files from here. Then arrange them to suit the video. We're just going to render this out as a video without sound. So with everything set up, we need to pick an output folder. So let's just select the folder icon, navigate to where you're going to save this video file out. Again, in my project folder, I can create a new folder, rename this Output Video. Then double click inside. Now accept this. Then to render the animation, let's come down to the Render menu and Render Animation. That will run through and render out a video file, and I can speed this up. When that completes, I'm going to double click my video off screen. This starts playing in VLC, which is a free open source media player available to download for free. Hopefully that was a helpful introduction series to Blender editing and some of the other tools you'll find within the application.